Okay, if you have a reaction like this and you need to balance the redox, remember there's 7 steps to it. And in your book, none of these subscripts are listed, but on your test they will be. So remember, the first step is to break this into an ionic equation, and you're only going to break apart the ionic compounds that are aqueous. And if the way you're going to look for this is if you've got groups of nonmetals, you got to keep them together. So in this case, with the this is sulfuric acid that I'm breaking apart, but I'm not breaking apart the SO4. You guys should recognize that it's a group of nonmetals. You should recognize it as sulfate. Okay, I've got the 2 iron. They're a 3+. You can tell by the way it pairs with the sulfate. 3 sulfate. And then my liquid water, which I'm keeping together. Okay, I'm going to erase these subscripts here just to make some room for myself, because now it's time to assign oxidation numbers. Okay, hydrogen is always a +1 unless it's with a metal. Oxygen is always a -2 unless it's with a peroxide. And in this case, it's with a peroxide. And in that case, oxygen is -1. Remember that all of your oxidation numbers within a compound have to add up to their overall charge. And in this case, peroxide is 0 as an overall charge. So the 2 -1s and the 2 +1s add up to 0. So that works nicely. Okay, the iron takes the oxidation number of its charge. And for the sulfate here, the 4 oxygens and the 1 sulfur have to add up to this -2 charge here. What you've got is 4 oxygens that are each at -2, giving you a total of -8, which makes the sulfur a +6. Hydrogen's +1. Here we got the sulfate again, so we'll just repeat those numbers. Here, the iron's oxidation number is its charge, and here we've got the sulfate again. And then now we've got oxygen, which is water, which is pretty straightforward. The oxygen in this case is not the exception like it was over in the beginning with the peroxide. So it's a -2, and each of my hydrogens are +1. Okay, so now, excuse me, now we can look and see which elements are changing. We've got oxygen going from a -1 to a -2. I'm not going to focus on it in the sulfate because iron is the only other thing that changes. And so by being able to cross out all the sulfates and this hydrogen right here, it makes this problem a little cleaner. Now it's time to write out the oxidation half reaction and the reduction half reaction. So that's the next step. Oxidation half reaction is pretty easy. You've got iron 2+, this going to iron 3+. Balance the charges, or balance the atoms, already done. Balance the charges, you had an iron that was losing an electron, so we're done with that one. The reduction half reaction is a little bit more complicated, and what I failed to mention in the beginning of this is that this problem is in acidic solution, which means I've got hydrogen ions and water that I can help use to balance this equation, because if you look at it, and I'm going to leave a little space for a reason, I've got hydrogen peroxide going to water, and no matter what I do to the coefficients out in front here, I can't get it balanced because I've got 1 extra oxygen compared to here. So I can use my waters on this side to help me balance the oxygen. So now I've got 2 oxygens on this side and 2 oxygens here, but I've got 4 hydrogens now. So what I can do is I can add 2 more hydrogens on this side of the equation, and that will help me balance it out. Now also, just to kind of consolidate this, I'm just going to add a 2 here and erase this guy. Okay. Now I got to balance my charges because I've got 4 hydrogens and 4 hydrogens, and I've got 2 oxygen, and I got 2 oxygens. So it's balanced, but now I got to balance charges, and I think it helps if you write the oxidation numbers of the thing of interest. So I've got 2 oxygens each going from a 1- charge to a 2- charge. And since I have 2 of them each gaining an electron, that means that I need to have 2 electrons on this side of the equation. Okay, and now I'm also going to delete that just to clean it up. So my half reactions are balanced. Now if my half reactions are balanced within them, I need to balance between them. And if you notice, I have 2 electrons here, but only 1 here. So if I multiply this whole equation through by 2, the oxidation, 2, 2, and 2, now I've got 2 electrons being given off and 2 electrons being accepted. And so that within the half reactions, the electrons are balanced. Now it's time to just add up the equations. And my electrons are going to cancel because I've got equal amounts on equal sides. And so now what I'm left with is 2 irons, a peroxide, 2 hydrogen ions, going to 2 iron 3 pluses, and 2 waters. And at this point, you can be done. This can be your final answer. But if you want to go for extra credit, you can try and piece this equation back together so that it looks like the original. What that will give you is, I've got my 2 hydrogen peroxides. If you look, that pairs up very nicely between these 2. And this one's a little easier than what I would ask you to do, but this is the basic idea. Then you've got 2 iron 2 pluses, and those need to pair with as iron sulfates. I've got 2 hydrogens. Those are going to pair up and become the 2 hydrogens in sulfuric acid. And now I have 2 iron 3 pluses. Those are going to turn into Fe2. Oops. Fe2, SO4 and then I have 2 water. This is an easy one, but that's what you would need to be able